Welcome to Knowledge Search channel. In this video, we are going to discuss about a case study on, for example, a linear and a non-linear network. A case study which will give you more clarity of understanding and distinguishing between the linear and non-linear networks. I will also explain with some examples which will make you more clear in understanding the comparison between the linear and non-linear networks. So without any further delay, let's go into today's topic. So to have a small brush up, so we were discussing as a series of lecture series. So we have discussed all the 4 different classifications in the previous series, and here I am going to give you some case study on linear and non-linear networks, which is the first way of classification of the electrical network types. So first way of classification is linear and non-linear network. And what do you understand from this linear and non-linear network? A circuit whose parameters like resistor, capacitor, inductor are always constant, irrespective of change in time, voltage and temperature, are called as a linear network. So for example, if you take any circuit, the resistor, inductance and capacitor parameters are not going to change its value throughout the time, for the entire time. That is called as a linear network. Okay? As well, the linear network should always behave the Ohm's law, superposition theorem, and it can be easily solved using the basic mathematical equations. So irrespective of change in time, voltage and temperature, the network parameters remains constant. So those networks are called as a linear networks. That's all is about a linear network. Then what do you mean by this non-linear network? A circuit parameters which changes their values with respect to change in time, temperature and voltage are called as a non-linear network. So for example, if particular network is going to change its value with respect to time, or it is going to change its value with respect to voltage, for example in case of diode, until the cut-in voltage it behaves as a open circuit, whereas above the cut-in voltage it behaves as a short circuit. So diode is a perfect non-linear network. So those circuits which have the diodes are called as a non-linear network. Okay, so because for different voltage levels it behaves in a different way. So these type of circuits, the Ohm's law and the superposition cannot be applied directly. Okay, there should be some methodology in order to implement those things, okay, with respect to time and other things. Whereas in case of linear networks, it can be applied. Ohm's law and superposition theorem can be applied easily. Okay. So as we have discussed, so let us go into some case study. See, for example, in case of linear network, if I am giving a 10 volts as input, okay, if I am giving a 10 volt as input, I will be getting 2 volt as output. Okay, it is a network, so it is a linear network. So for 10 volt input, I am getting 2 volt output. Similarly, if I give 20 volt input, that is, I am going to double the input voltage. Okay, instead of giving 10 volt, I am giving 20 volt. And if my voltage is also doubled from 2 volt to 4 volt, then that particular network is called as a linear network. So there are two. So this is called as homogeneity. So in case of what is meaning homogeneity? When the input voltage is doubled, the output voltage is also doubled. Similarly, there is one more property called as additivity. So now we will discuss what is that additivity. See, for example, if you add these two, that is 10 volt plus 20 volt will give you 30 volt. And for example, in previous case it was for 10 volt, I took it as 2 volt. Here, if I give 10 volt, it is 4 volt. For 20 volt, it will be 8 volt. So if you add the input voltage, you can see that you will be getting 30 volt. If you add the output voltage, it is 12 volts. So E1 plus E2 will be directly proportional to the summation of R1 plus R2. So additivity is also good and as well the homogeneity is also good. So this type of circuit, so this is a case study which I have given you some practical example in order to understand much more clarity with what is the difference between the linear and non-linear network. Hope you are all clear. Okay. So now let us go into some case study videos which we are discussing inside the class related with our electrical domain. So some of the glimpse.
Today we have Benny, Dinesh Kumar, Saran Kumar. So here in this video we are going to discuss about EPTP. So as you all know, EPTP is nothing but mechanical power transmission part and EPTP is nothing but electrical power transmission part. So both are having its own plus and minus, and based on this we are having different types of architectures in all the series. So let us start the sessions related with this. Now, Dinesh, can you tell me what is MPTP and what is APTP?
So thank you, and if you really like this video, please give a thumbs up, and if you have any comments, please let me know. And as well, if you like this video, please share with someone, and if you like the videos which I post in this channel, please give a subscribe to this channel. Thank you all.